Hello and welcome. This is Dan Explains, hosted by me, Dee Yan. In 1935, an Austrian physicist named Erwin Schrödinger proposed a thought experiment that, at least according to an, at the time, new theory, a cat could both be dead and alive at the same time. He didn't propose a thought experiment because he believed the theory. He proposed it because he didn't believe the theory, and he was attempting to point out the absurd possibilities if it was correct. He was wrong. Let me explain why. Before I begin, I'd like to say this video is closely related to my video on the Heisenberg uncertainty principle. So if you haven't already seen it, please go and watch it. Link in the description. Don't worry, I'll still be here when you get back. Also, I'll be splitting this video into two parts. It would go for 15 minutes if I put them together. And I have a feeling people would need to digest part 1 for a bit before moving on to part 2. Okay, let's begin. You should recall from that video that the Heisenberg uncertainty principle says the more you know about something's speed, the less you know about where it is, and vice versa. Although this happens on such a tiny scale, it doesn't appear to have much of an effect on us or our everyday lives. However, there are ways this quantum randomness can affect us on a large scale. Enter Schrödinger's cat. Some of you may have heard of the idea, which to most who misunderstand the thought experiment setup sounds ridiculous. For those who don't know, this is the setup. Suppose you put a cat in a box. It's completely sealed off from the outside world while it's inside the box. With it inside the box is a tiny sample of radioactive uranium and a sensitive Geiger counter to detect if the uranium releases any radiation. Attached to the Geiger counter is a mechanism with a hammer that will swing the hammer and smash a vial of cyanide gas if the Geiger counter detects radiation, which of course would kill the cat. Radioactive decay is something that happens on an extremely tiny scale and is completely random on a quantum level. Uranium has a half-life of 4.5 billion years. What that means is it will take, on average, 4 billion years for one atom of uranium to decay and release radiation. It doesn't matter how long the atoms have been around. The atoms aren't aging. So if you have pure uranium, it'll take 4.5 billion years for half of it to decay and another 4.5 billion years for half of what's left to decay, and so on. Now you put just enough uranium in the box with the cat that, on average, it takes 20 minutes for the Geiger counter to detect a radiation hit from the uranium and release the gas, killing the cat. Again, when the radiation is released is totally random. It could take 5 seconds, 5 minutes, or even 50 minutes. 20 minutes is just an average. So, this is the question. If you close the box and wait 10 minutes, is the cat dead or alive? So, at this point, it seems like it's a 50-50 thing, right? Well, Schrödinger says the cat is both dead and alive at the same time. This is something called a superposition. Of course, it seems absurd on its face. Obviously, the cat is one or the other, right? I mean, under normal circumstances, that would be correct. But what people miss is what completely sealing the cat off and the apparatus off from the outside world actually means. It doesn't only mean that you can't tell what's going on inside the box. It means essentially the same thing as throwing the box into a black hole. No information in, no information out at all. It's like the cat is its own little pocket universe. That is the case where the cat is dead and alive at the same time. taking something on a macro scale and having its fate determined by something that's fundamentally random at a quantum level. If it's not transferring energy or information, which really are the same thing, with the outside world beyond the box, the fate of the cat becomes just as unknown to us as the decay of any one of the uranium atoms. With current technology, this experiment is impossible to set up on a large scale. However, it's one of the reasons why things that are very tiny are dominated by quantum effects. Something the size of an atom is much more likely to fly off and interact with absolutely nothing, and because of the uncertainty I mentioned in my video on the Heisenberg uncertainty principle, where exactly that atom is becomes more and more uncertain as time goes on, and it gets further away. So at this point you may be thinking to yourself, even if you could perform the experiment, nothing about it proves the cat inside the box is dead and alive at the same time. This is where Bell comes into the picture. No, not that Bell. This Bell. John Stuart Bell. People like Heisenberg and Einstein, yes, that Einstein, thought there were reasons things appeared to be in two states at the same time. That they weren't both suddenly and randomly becoming one thing or the other when you open the box. They called these reasons hidden variables. Bell postulated something now called, no big surprise, Bell's theorem. I'm not going to go into the details of the theorem itself, but it provided a way to test if these hidden variables existed or if they didn't, and the cat would be truly dead and alive at the same time. Basically, if hidden variables existed and quantum physics is wrong, there's an experiment you can perform where all the numbers add up. If the hidden variables are wrong and quantum physics is correct, they won't add up. In order to understand that, however, you need to learn a little about quantum entanglement. What is quantum entanglement? It's what Einstein derogatorily called creepy action at a distance. Since something that could literally be in two states at the same time implied faster than light communication via quantum entanglement. Since Einstein said nothing can travel faster than light, you can rest assured he didn't like the idea. This is as far as I'm going to go for part 1. So don't miss next week's video for part 2. If you like this video, please press the like button, subscribe to my channel, and ding the bell to get notified when I post new videos. Also, please support me on Patreon, link in the description. The more people who support me, the more time I can dedicate to making videos like this one. So, until next time, have a great week.